In this video, we're going to go over section 10.6 from our textbook, which is on more about solving trig equations, and in particular, working with our double angle and half angle identities that we saw in section 10.3. So let's do this example here. We want to solve this equation over our interval from 0 to 2 pi. And so the first thing we're going to do is recognize that we're dealing with a double angle here. We have sine of 2x. Now, like I said, from section 10.3, we know that this double angle is going to be equal to this guy here. All right, so we'll use this to solve this guy. We're going to rewrite sine of 2x as 2 sine x cosine x. This is equal to 2 cosine squared x. Now, we have a 2 on both sides of our equation, so we'll divide by 2 to cancel those guys out. Then we'll get sine of x cosine x is equal to cosine squared x. Now, moving this cosine squared x to the other side of our equation, we'll get sine x cosine x minus cosine squared x is going to be equal to 0. Now notice we have a cosine x in both of these terms here, so we can pull that guy out. We'll get cosine x times sine x minus cosine x, and this is all equal to 0. Now this just becomes a simple case where either cosine x is going to be equal to 0, or sine x minus cosine x is going to be equal to 0, or both. So we have cosine x is equal to 0, or sine x minus cosine x is equal to 0. Now if cosine x is equal to 0, then this means x must be either pi over 2 or 3 pi over 2. So those are our two solutions here for x. And then in this case here, notice that this is just sine x is equal to cosine x. Okay, so we want to figure out for what values is this true. Going back to our unit circle, the only time that cosine x is equal to sine x is when x is equal to pi over 4 or 5 pi over 4. So those are our two solutions here. Alright, so this tells us our solution set is going to be these 4 values here. For x values within this interval. Alright, so let's do this example here. We want to solve this equation over this interval from 0 to 2 pi. So notice we have sine x times cosine x, and this is really close to the double angle identity we saw in the last example. But if we were to multiply both sides of this equation by 2, we would get exactly 2 sine x times cosine x is going to be equal to 2 over 4, which is 1/2. And this is our double angle identity for sine of 2x that we saw in the last example. So we'll rewrite this guy as sine of 2x, and this will be equal to 1/2. This tells us for sine of 2x to be equal to 1/2, this angle 2x must be equal to, going back to our unit circle, pi over 6 and 5 pi over 6. Sine here is 1/2. So 2x is going to be equal to pi over 6, and 2x must be equal to 5 pi over 6. Now something to note here, that if we were trying to find all solutions, not just over our interval from 0 to 2 pi here, this would be pi over 6 plus multiples of 2 pi, which we would denote with 2 pi n, where n is any integer. Now, we want to figure out what x is, though. So what we're going to do is divide both sides of both of these equations by 2 to get x alone. we'll get x is going to be equal to pi over 12, since pi over 6 divided by 2 is pi over 12, plus pi n. And similarly, x is also going to be equal to 5 pi over 12 plus pi n. So this would be our solution set, both of these guys, if we were looking for all solutions, not just in this interval here. However, what we're going to do is we're going to let n, in this case, be equal to 1. And we want to do this because we want to make sure that we're catching all of the solutions within this interval here. So in this case, if we were to let n be equal to 1, we would get pi over 12 plus pi, which is going to be equal to 13 pi over 12. Now this is going to be in our interval from 0 to 2 pi. So this tells us that this is going to be a solution in our solution set. And similarly, we're going to let n be equal to 1. So we're adding pi to 5 pi over 12, which is going to be 17 pi over 12. And again, this is also in our interval from 0 to 2 pi. So we're just doing this to make sure that we caught both of these solutions. Now, if you were to let n be equal to 2 or greater, those solutions would not be in this interval. So our solution set in this case would be pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. These are all solutions that are in our interval from 0 to 2 pi. Alright, and then, like I said, if we were asking for all solutions, then our solution set would just contain these two here. Alright, so the next example we'll look at is this one here. We want to solve this equation over this interval here. What we'll start off by doing is trying to get sine of this half angle here, x over 2, by itself. So we'll divide both sides by 2. This gives us sine of this half angle, x over 2, is going to be equal to the square root of 2 over 2. Now, similar to the last example, this means that this angle, this half angle, x over 2, must be equal to pi over 4 and 3 pi over 4. So we're looking for values of this half angle, where sine of this half angle is going to be equal to square root of 2 over 2. So x over 2 is going to be equal to pi over 4, and x over 2 is going to be equal to 3 pi over 4. Now, getting x alone, we're going to multiply both sides of both of these equations by 2. This gives us x is equal to pi over 2, and x is equal to 3 pi over 2. Now, in this case, this is our entire solution set. For this interval from 0 to 2 pi. Any other multiples of pi, or 2 pi in this case, would be outside of this interval here. Alright, and let's look at the last example here. We want to solve this equation for all exact solutions in this case. So now we're not just looking at solutions within the interval from 0 to 2 pi. So we have this equation, and again, the first thing we want to do is try to get our trig function alone. So we're going to add the square root of 2 on both sides of this guy. We'll get 2 sine 2x is going to be equal to the square root of 2. Then we'll divide both sides by 2. This gives us sine of 2x is going to be equal to square root of 2 over 2. So just like the last two examples, this tells us this double angle here must be equal to the angles that'll make this guy equal to square root of 2 over 2. So, going back to our unit circle, we'll have sine is equal to square root of 2 over 2 at pi over 4 and 3 pi over 4. But in this case, we want to find all exact solutions. We're not looking at a particular interval. So we're going to add our multiples of 2 pi. where n is any integer. Now we want to solve for x, so we're going to divide by 2 on both sides of both equations here. We'll get x is going to be equal to pi over 4 divided by 2 is going to be pi over 8, and then 2 pi n divided by 2 is just going to be equal to pi n. And similarly for this guy here, we'll get 3 pi over 8 plus pi n. So this tells us then that our solution set is going to be pi over 8 plus pi n, and 3 pi over 8 plus pi n. And this is where n is any integer. So in this case, this would be all of our exact solutions. We're including many, many multiples of pi. Alright, so that'll be it for this video.